need that. These are supposed to be like doctor stuff, right? Apparently, no. So we are actually trying to bring some of these technologies to construction to make work safer. So this is where this usability evaluation really came into the picture, because you can develop all these technologies, but you don't know whether the construction worker or the construction engineer would really be able to use it or not. Let's say you have so many bugs in your system, and when somebody is trying to calculate some load stress or something like that from the informatics system, it's not just giving you the results that you're looking for, or maybe it's making errors that you're not aware of. So that's going to increase your cognitive load, your stress, your frustration, and you're basically going to hate that software, right? So you're not even going to use that. So this is exactly why usability evaluation is so much important, because we really need to understand whether this is something that's usable, right? Um, so in order to do that, what we did was we took 40 participants, and all these participants were actually construction students. And after that, there is something that we did was very interesting. We did not only test out our new platforms, but what we did, we also asked the participants to try the same analytic steps across Excel, MATLAB, as well as InnerSense and ActionSense. The reason why we did this was that's when we have like a basis of comparison. We can see that, okay, whether Excel was better or the development that we just made is working better. And I have some of those results to show you today. All right, moving on. So on the next step, oh yes, sorry, just almost forgot. Yes, so while we collected all this data, we also collected their physiological signals like EEG, and we also collected their eye tracking data. As you can see, my participant is wearing this glass. This is the eye tracker, and on the head, whatever you can see, this is the EEG. And this is where she is basically trying out our new informatics solution. And at the same time, we also collected some subjective feedback, which is extremely important to formalize your quantitative data. So moving on, let's talk a little bit about the second phase of the data collection. So once this usability evaluation was done, then we took these solutions to the actual classroom. Okay, so this is where we deployed it across 110 students at Virginia Tech, University of Texas at San Antonio, as well as Texas A&M. And we only did not have undergraduate students. We had both undergraduate and graduate students try out our platform. And they did not only try out our platform, but these platforms were embedded into their coursework as part of their semester. So basically, they used these platforms to complete their quizzes, their assignments, as well as their final exam. So basically, they were graded on how well they can use this technology to perform their uh, instructional tasks. So let's talk about some of the data that we collected. Here we collected their self-efficacy survey assignments, and importantly, we also collected their mouse tracking data in order to understand their web browsing behavior as well as usability and usefulness. So moving on, I'm going to go a little quickly on some of the next slides just to have enough time to show everything, also give the opportunity for you to ask questions. So let's take a look at what the results really look like. So this is just very basic. So we saw that whenever we compared Excel and InnerSense, so this is Excel, this is InnerSense, we could see that the SUS, which is the system usability scale, whenever any new product is coming out in the market, this is something that is used in a standard manner. We could see that Excel actually performed lower than InnerSense, and there are some other interesting patterns that we were able to find. Um, so yes, this is one of the interesting parts. So this is basically eye tracking. So I showed you that we used eye tracking technology to understand their web browsing or informatics browsing behavior. So when you wear that glass, it has cameras inside that can basically read your eye movements. And as researchers, we are always collecting all that data because these are useful behavioral information for us. So from here, we could see that the visual behavior in Excel was much more demanding compared to inner sense. So what this does it so what is the problem when you have when one informatics or one software requires you to devote too much visual attention? So you actually become frustrated and you don't actually like that. So this is the answer we actually saw in our last slide. So this is what tells us that people don't like that. Another um, Another evidence that we have is the EEG analysis, because now we're talking about visual stuff. We're saying that, okay, Excel is maybe a little bit more, it's just a little bit more tedious to use, and maybe in a sense it's easier to use. But how do we know for sure? Somebody could be lying to us, somebody could be just trying to be nice and not telling us the exact information. So this is where the EEG or neurocognitive assessment really comes into the picture, because this is where we can actually tell whether interaction with this kind of software elevates your cognitive stress or not. So this is exactly what we did over here. We measured certain parts of their brains and we collected all this data. Now there are some kind of pre-processing that we also need to do. The reason why we need to do that kind of pre-processing is because when we collect this EEG data, there are a lot of noise and artifacts. So basically, we have to clear up all that before we can actually get the cognitive load signal. So moving on, let's take a look at some of the results. So this is NASA TLX score, which is subjective, which is basically like a survey. We're asking them, okay, which one did you feel like was more stressful? So as we can see from the results, all the participants say that Excel was actually more demanding, but we cannot take their words for it, right? Because this is where they could actually be like, just lying just to be nice to you. They might be telling, oh, okay, yeah, I like inner sense and I hate Excel. But you should not um, take it for their word. So that is when we can actually look into their objective or behavioral measures, right? So behavioral measures are not going to lie, because this is something that's going to tell us that whether some of the brain activities have been stimulated because of this interaction. And this is exactly what we could actually see from the behavioral data as well, that initially the new informatics solution required the users to devote more cognitive workload. But as they went by, we could see that Excel actually surpassed in terms of cognitive workload in certain brain regions. This is a little complicated, but if anybody is more interested about knowing more about it, just feel free to reach out to me, okay? All right, so we'll shift gears a little bit. We will now talk a little bit about how we're injecting artificial intelligence in many of these workforce development or human-centric technologies. So the experiment that I showed you, so we did not just stop, we did not just collect the data and report the statistical analysis. We wanted to take this one step forward. So we collected all this eye tracking data. And after collecting this data, we did some kind of pre-processing to it with gaze and AOI mapping with the help of ground truth data. Then we did some data labeling, oversampling, as well as model training to the point where we could evaluate the performance of these models. Now, what did we really train the machine learning models on? So basically, what we did was when the users were using these uh, platforms, we collected all this eye tracking data, and now we trained various machine learning models in a way so that these models can detect exactly where you are looking at. So basically, if you follow my pointer, so let's say that you are looking at here right now. So the computer would be able to automatically detect this is where you're looking at. So if you're looking at this position, but you're supposed to be looking at here, that means that you are distracted. You're not looking at the correct. So let's say you have an exam tomorrow, you're trying to study, and this is what you should be reading, but your eyes are over here, which is a problem, right? So this is when your system can detect this and it can send you automatic alert that, hey, you are distracted or maybe you need to take a rest. So how it works is that maybe let's say that you are looking at this box So when you're looking at this box, the computer would be able to automatically detect that your eyes are locked into this position. And with that, it can provide you with need specific assistance. Okay, so moving on, let's talk a little bit about some of the results that we got from here. So from here, we got really good results. We had high performance, like all of those were more than 85% accuracy. So with this kind of technologies, what we can really do is we can leverage the visual attention. We can accurately detect without human intervention the visual attention, visual focus of the students, their engagement level, their level of interest, as well as their level of content comprehension. So, what this does is that focus detection can streamline informed content delivery in order to reduce distractions as well as reduce cognitive workload. Because I think I have made it pretty clear by now that cognitive workload is a really important parameter whenever we're talking about construction. So moving on, I'd like to talk a little bit about what we also did with the EEG data. So the EEG data, we did not just stop there, because imagine once this EEG signal starts to come out, what if there is a situation where the cognitive load is going to be too high? Now, who's going to detect? If you really want to detect that, that means that you have to sit somewhere, you have to constantly monitor that person, you have to constantly monitor all those waves to understand what's really going on. But that's impossible. Nobody can look at all these graphs to understand when the cognitive workload is going high. So this is where we took it one step forward. We took all these models, we denoised all this data, and then we took the help of deep neural networks. We used LSTM models, we used convolutional neural networks to the point where we could actually train all this EEG data so that these models can detect even before the cognitive workload occurs. Because it's important, because once the cognitive stress or overload has occurred, that's when you're supposed to make mistakes. And if you're making any mistake in construction, people might die. So you cannot afford to wait until your cognitive workload is going high, but you need to have systems in place that can basically detect that cognitive workload or forecast that cognitive workload before it is happening, just like weather forecasting, just like how we forecast the rain before it happens, right? So this is exactly the types of concepts we are trying to bring in construction. Moving on. Okay, so I'm going to shift the gears a little bit. We'll talk a little bit about some of the RCS Lab features, all the cool stuff that is happening over here. So first, let's talk about wearable robots. I'm not sure how many of you are familiar with wearable robots, but this is something that's basically becoming really popular in construction these days. So there are whole body suits, there are back support exoskeletons, there are arm and shoulder support exoskeletons. So these are basically being incorporated in construction because of the high injury rates. Construction workers are 5 times more likely to develop back related injuries or musculoskeletal related injuries. So, this is why now construction industries are really putting a focus on seeing how they can integrate this within their routine construction work. So when we talk about that, so our lab has some of this equipment. We recently got the AI-powered Exia, which is one of the most latest exoskeletons out there. This is AI-powered. That means that whenever you wear it, it's going to read your body and it's going to adjust the support level automatically. Then there is apogee and shoulder support exoskeletons, and there are active and passive different kinds of exoskeletons. So our lab has both types. And we also have other mechanisms, for example, muscle activity evaluation system. So whenever people are wearing these exoskeletons, we do not know whether that's really helping people or this is making the task even more difficult. So this is where we can actually go ahead and put all these sensors on their body to really study how their muscle activation is functioning. Um, we have already done some papers on this. We have put this exoskeletons on folks. We have collected data from them. And right now, we're actually expanding this research. We are taking some of these exoskeletons and we are trying to modify it with some more intelligent sensing technologies. So stay tuned. I think maybe in the next couple of months, you'll be able to see some really exciting technologies moving forward. Um, all right, so we'll talk a little bit more about laser scanning. This is also another capability that the RCS Lab has. So this is one of the terrestrial laser scanners. So this is a huge transition from theodolites that we are used to seeing. A lot of the construction companies are right now investing millions of dollars into this kind of technologies because it just makes the work way more easier for you. So this is how it works and how it is better. It has better accuracy, precision. You have dense point cloud creation, like only 3 to 6 millimeter point to point distance, which basically creates that dense point cloud model for you. The efficiency wise, you can do rapid scanning within 3 to 4 minutes. You have the scan of the entire facility. You don't have to expose your workers to unsafe situations, and also you just get into better decision making. So um, the video that you are looking at right now, this is actually a handheld or like a movable laser scanner. So we have that. So basically, with that, you can roam around and you can collect all this information. At the same time, we also have terrestrial laser scanner. So with the help of that, we can basically take the measurements of various stockpiles, as-built structures, and we can calculate all those points and get volumetric measurements and many more. So that's not all. There is some very interesting things that are happening out in the market right now. So with all that point cloud, now you can also merge with virtual reality. So in virtual reality, you can basically deploy your point cloud. And now, with the help of this virtual reality, you can also explore your point cloud. And one of the most interesting factor of this is that, let's say that you are in Bangladesh, but you're actually managing a project in California in the US. So basically, as an engineer, somebody can take all these laser scans and send it to you. You can be in your office in Bangladesh, and you can basically just wear your headset and look at all these as-built structures um, to actually supervise or advise how the on-site team can move forward. So basically, what you're doing is you're doing remote collaboration. So moving on, with the help of virtual reality, augmented reality. I have also been involved with many other projects. This is a project that we started to create when back in COVID because we could not take the students in the site. So we created this environment where students can not only interact with the construction equipment, but they can also deploy various kind of sensors. Not only deploy, but they can also collect the data. So while they were doing their stuff as researchers, we were collecting all their eye tracking data. So with the help of this eye tracking data, we also trained various deep learning models. And there is a paper on this as well. The link is down below. If you're interested, you can definitely check it out. And then another active area of RCS Lab is end user informatics development. So this is Octave, another end user platform. This is quite interesting because this is very simple. What you need to do is just get a very simple GPS device. You can put it on any construction equipment you want. Once your construction equipment has basically completed all its cycle, you can now collect this data and put it into this environment. And with that, you can basically see your data trajectory. You can define your loading cycles, dumping zones, all these things. And from that, you can basically see whether your equipment has been idling for some time, whether it has been productive or not, whether it has been burning a lot of, like it has been um, lately doing a lot of fuel consumption. Maybe the equipment needs some kind of maintenance or not. So with the help of all these spatial data, spatial temporal data, you can basically get into all those insights. Moving on, we are also working currently on one of these heat straps web app development, where we're using various deep learning models and weather data to merge them together so that construction practitioners can use these kind of platforms to basically make better decisions. That, okay, should I deploy my workers at 12 p.m. In the afternoon, or should I deploy them at night? If the decision support platform tells me to deploy them at nighttime, there is obviously some kind of mathematical calculation that has gone behind, which has seen that if you deploy your workers right at this like sunlight, their productivity is not going to be that much. They might go into dehydration, heat stroke, other type of illnesses. So your productivity might not be even 30%. So that is when you basically need to utilize informatic solutions like this to better make decisions. So moving on, just to recap everything, these are some of the exciting activities like reality capturing, mixed reality, heads-up informatics, drones, and sensing technologies that we have in the lab. We are also looking into robotics, informatics, machine learning, point cloud modeling, all that sort of stuff. Other than that, we are very active in terms of outreach activities. We are very active with student collaboration, mentorship, and all that sort of stuff. And so, with that, I would really like to open up some opportunities for the Asanullah students as well. So, this is something I would like to present to you. So, I will be actually mentoring and moving with some collaborations with some Australian students, particularly students who are really interested in scientific research, as well as interested in some of the stuff that we are doing in the RC's lab. So if this is something that you are interested in, please feel free to fill out the survey. Again, this is a very limited opportunity. So try to give your best shot. We will see who we can pick up, but try to do this as soon as possible. As I mentioned, it's a limited opportunity. But with that, I would like to come to the very end of my presentation. Thank you very much, everybody. And here's my LinkedIn as well. Please feel free to add me on LinkedIn. I'd be more than happy to answer any questions that you have. And yeah, so I think that brings me to the end. Thank you very much, everybody. And just let me know if you have any questions, and I'll be more than happy to answer them for you.
Dr. Khalid, can you hear me? Yeah,
Yes.
I'm Galib. Excellent work, a very nice presentation. Um, so my first question is, all the works that you showed us today, was all this done in your PhD, or you showed your PhD works as well as what you did after that in your ArcSys lab?
I'm extremely sorry, Tasin. I think something is wrong. Do you mind repeating the question once again? Sir, sir, this question was from Galip, sir. Sir, kindly.
Yeah, sure. Khalid, can you hear me now?
Yes, sir. Galip, sir, how are you doing,
Yeah,
sir?
I'm fine. I'm fine. How are you doing?
I'm doing well.
Yeah, excellent work and very nice presentation.
Thank you.
I was wondering, like all the works that you are showing us today,
Mhm.
were all of these based on your PhD research, or you showed us your PhD research as well as what you did after that in your ArcSys lab?
Perfect. Thank you very much for that question, sir. So, the first portion of the work that I showed, so
Mhm.
let me see. So, the first portion was basically my PhD work. So, we did all these informatic system development, and we deployed it across various universities. So, that was part of my PhD dissertation.
Mhm.
And After that was done, now we are actually expanding some of those informatic solutions. We're trying to bring in more sensors, more analytical models inside. We are also not looking into ergonomics only, we are also looking into heat stress. In the coming days, we'll be also looking into some kind of cognitive stress related wearable detection system. So basically, the first portion was something that I did for my PhD, but from that, I'm basically now trying to branch out into different
I
areas.
see. Okay, 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 excellent, excellent. So I am kind of involved in a few. Let me tell you this first. So I actually am focused on structural design improvement of bridge structures, my research area, and what I'm trying to do right now is kind of to use some AI and optimization algorithm to kind of basically improve the structural design of bridge
Hmm.
structures, different parts of the bridge, for example, the girder part or the pier and foundation parts and so on.
Right.
So basically, what we are trying to do is to propose some improved or next generation designs of those members. For example, the improved designs of the girders or improved designs of the piers and foundations and so on. But
Hmm.
what we are facing is that the construction industry are reluctant to kind of adopt those changes. The construction laborers or the fabricators are kind of they want to stick to what they were used to do. Uh, Although, so let me clarify a bit more. I am involved in one of the projects funded by Alaska DOT, Alaska Department of Transportation,
Hmm. Yep.
where we actually proposed the next generation's girder sections or girder designs for them.
Hmm.
And the DOT is very excited about this transition, but not so much cooperation we are getting from the fabricators.
Hmm.
As I said, they want to stick to what they are currently using or doing.
Right.
So your presentation actually excites me a lot. I think I want to hear this from you. Is it possible to kind of measure or quantify the relative safety issues or like construction industry related issue
Hmm.
of those two designs, the old girder designs and the new girder designs? The new girder designs are deeper in depth and
Hmm.
way more. The transportation installation will be difficult and so
Hmm.
on. So just wanted to know your thought. Like in such projects, we from structure point of view, we just kind of are lean to think up to that point where we just propose the new design, but not beyond
Hmm.
that. What would be the impact of that new design and so on? So what do you think your lab can do to estimate the relative? You see my point? So yeah.
Yeah. Yeah,
Mhm.
perfect. That's again very very exciting project. I mean, bringing in AI for structural girder design. I think this is where the future is going. So a lot of the design standards will be, I think, in that domain, like using AI to design. So I think that is a very timely research. Our lab mostly there is this thing that we do not have structural capability. Although at NGIT, I have colleagues who do like a lot of structural testing. So I believe that this is something that would be more of their expertise, where they have the lab to test that kind of new structural design that has been done by AI versus the old design. So that would give some kind of leeway to test it out. From our side, folks who are more in construction engineering, what we can definitely do is we can look into some kind of structural health monitoring related technologies to show whether, like under various conditions, which one is performing better. I mean, just to show, I mean, if the agencies are still not comfortable accepting AI based, like AI generated design or utilizing AI to design those girders, I mean, I think those could be two ways to actually convince them.
So to follow up to what you just said, Khalid,
Mhm. Yeah.
for example, the old girder sections for the girder designs
Mhm.
weighed less than the new ones. They were shallower than the new one, and its span length was lesser than the new ones and so on. So is
Hmm.
it possible to quantify which girder construction and transportation and installation is safer from construction point of view?
Absolutely.
Uh, you see my point? So
Abs-
I was
yes.
actually alluding to that aspect of the research or
Yes,
research.
yes, absolutely. I think I now understand your point better. So, absolutely, that's possible because right now we're actually working in one of those areas where we are not only trying to see all this sensor data, but we're trying to see how this sensor data, these outputs, can be connected to construction schedules, which is
Mm,
one of the most important things. Now, when you're bringing in new girder design that has a different footprint, um, you want to see it has a different weight, it has a different handling procedure. You
mm.
might need new construction workers who are trained to handle that new kind of garter. I don't know. Maybe that could
Right.
be
Yeah, yeah, right,
could
right. Right.
that
Mm,
could have a different installation procedure if it's a precast garter or something like that. So you have to account now. Do you also need to train your in-house workers how
right,
to
right.
launch that garter? So and while doing that, what are the risk factors? Like we have to do risk analysis for everyday job site to understand, to kind of predict those risks. So we can also factor in all those small points into a unified model to basically see that, okay, all these factors, do they really help or not? Okay, even if they're slowing us down a little bit, what is the bottom line? Ultimately, we have to look at the bigger picture. So if it increases safety, that means that you have lesser risks. If it increases safety risks, that means that you have to account for the insurance, compensation,
Mm,
wastage of labor, all these things. But if it increases safety risk but takes longer time, but it might be a better investment. So that is possible. Yes.
okay, okay. Thank you so much. Thank you so much.
Yes, you're very welcome.
So, if any of you have any questions regarding today's session, please turn on your microphone and feel free to ask our keynote speaker, sir, if any of you
Uh,
have questions.
Assalamu alaikum, sir. Khalid, sir. I am Mahin, current president of ACR student chapter. Am I audible?
Yes, Mohin, very nice to meet you. How are you doing?
I'm doing very well, sir. Thank you for your time. And I just want to share my experience and also I have a question. So my
Sure.
question is, sir, you showed here various advanced technology which can be used in construction. But as an engineer, obviously our first priority is safety of the structures as well as for the workers as well. But we also have to think about the cost of the project. Is there
Right.
any possibility that the cost of this process could become significantly higher than that of the conventional process? And if
Mhm.
so, would it still be practically acceptable and feasible for everyone to adopt?
Okay, so you're basically trying to understand that all these new technologies I'm showing, these are obviously very expensive, right? So how do we really integrate it into construction? Did I get your
Yes,
question correctly?
yes, sir. Yes, sir.
So
Yes.
that is a very good question, and this is one of the biggest challenge that a lot of the smaller firms are having. The bigger firms, it's completely fine. They can just go ahead and put out 5 million, $10 million that, hey, we need all these technologies. Can you create the entire framework for us? We always work with this kind of companies. They have the money. But I think your question is more appropriate for the smaller or medium firms who might not have the money or the expertise. So this is where our lab is also working on low cost technologies. Some of the sensors that you have seen, for example, the EMG sensors, they cost about $15,000. Now, if I ask somebody to spend $15,000 in their project just to ensure safety, they might not do it. So this is where we're looking into how we can make that entire device under $100. So if we can do that, I'm pretty hopeful that would be something that can be approached to various smaller construction companies. And the situation is pretty different right now in US because AI is revolutionizing. Even our president is basically putting in a lot of emphasis to uh, create all these industries or prepare all these industries so that they have AI capabilities. A lot of the data centers are being constructed now. If the smaller or medium-sized companies are not really utilizing all these sensing technologies, they're basically falling down behind in the competition. Somebody who's using the technology maybe can get the work done in 3 days, but in the conventional way, you need 1 month. And even in 1 month, you don't have accuracy of the data. You don't have reliability of the data because most of your data is coming from hand notes, field notes, or manual observation. Manual observation can have errors, so there are more chances of rework or quality related deficiencies. So ultimately, if you see that if you want to integrate or adopt this technology, maybe a one time investment, that's ultimately saving you money moving forward. That's helping you keep your workers safe. They're not getting injured, your workers are coming to work, you're not losing any time. And if your workers are safe, you don't have to worry too much about the insurance cost as well as their medical bills. So I would say that integration is something that everybody should look into more seriously because this is where the world is going right now with the help of all these technologies. So this is something we are also working on how we can make it more affordable for the smaller companies.
Thank you, sir. So basically, the construction firm has to invest more to get more efficiency and more safety.
Absolutely. Absolutely. No question about that because all the other industries in the US right now, they are more or less industrialized. They're under the factory. So all of those things are very predictable, but they're all under robotics and all that sort of stuff right now. But construction is something that is not predictable. Every day you have new workers, every day you have new job, everything is unpredictable. So as a human, how difficult is it really to understand what is going to happen tomorrow and make plans based on that? So basically you're making plans based on your experience. Now if you're a new engineer on the construction job site, what kind of experience do you have that would give you the authority to make that kind of life-saving decision? So this is where you should um, learn to use sensors. You should learn to use analytics, AI, all these things to help you make your decision, not replace your decision, but to augment your decision, right? So, yeah, that would be my
Yes, sir.
suggestion.
Yeah. Thank you, sir.
You're welcome.
Hello, sir. This is Sylvia. Am I audible?
Yes, hi Sylvia, how are you doing?
Hello, sir. So basically, I have a question.
Okay.
So my question is, how much time do you think the US needs to adopt all the technologies what you have mentioned today, like fully adopt and to be fully automated? How much time the US need? Then we can think about like how much time we need Bangladeshis. We can what our country Bangladesh need. But first, I want to know about how much time the US need to adapt all these technologies and be fully
Mhm.
automated in constructions. And also, I have another question: is that what's your opinion that should the US go for the fully automated in the construction industry, or it should be integrated like AI plus human effort? So this is my question: like, should we be integrated, or the all things should be like fully AI automated?
Very good. Great questions. Your first question, I would say that the landscape is changing very quickly right now. Every other month, we have um, companies visiting us in our university. They're asking us that, hey, can you please help us to integrate AI into this application? Hey, please, can you help us do this, do that? Um, that basically shows that there is an urgent need. Otherwise, they're just falling behind. When they will be fully automated, that is a very tough question. But we are already seeing we are already seeing the change in motion. Exoskeletons. previously designed for industrial workers. Now there are companies who are actually paying the universities to test out these exoskeletons to see if they can utilize it construction or not. So I would say that we are there, but quite not there yet. So it's I think the responsibility is on me as well as on you. You are all brilliant people to see how we can best integrate all these things in construction and how fast we can make construction a safer place. To answer your question number two, whether I suggest full automation or whether I suggest like it's like a 50-50, right, like a collaboration. So there is like a lot of debate on this. So autonomous, sometimes it needs to be autonomous. For example, there is like you have all heard of Chernobyl, right? If you have like a radioactive area where you don't want to put out your worker, this is where you want autonomy. You want somebody to go there, and you also want not anybody to be there to direct that robot, but that robot should be able to go there by itself and make decision on its own. So this is where a lot of the scientists are working right now, how to make it more autonomous. But I personally don't support full autonomy, particularly in construction. That is because of one of the reasons that I mentioned that construction is not like a car factory. We have people, we have all these dynamic work, so everything is unpredictable. So you still want to have some level of human supervision involved so that you know that there is always like a safety net. So it really depends based on the application, but I think there should be some kind of collaboration. I think rather than full autonomy, human robot collaboration or co working, coexisting together is something that could be much better.
Okay, sir, thank you for your answer.
You're very welcome.
Good evening, sir. This is Ruman. Am I coming through clearly, sir?
Yes,
Thank you, sir. Now, moving to my question. Before
sure.
that, sir, earlier you have mentioned that today's seminar mainly focuses on the impacts on manual laborers, right?
Hmm.
So, in labor markets where manual construction workers rely on physical labor for daily livelihoods, how can management ensure that automated productivity monitoring doesn't reduce employment opportunities or lower wages for frontline workers? Don't you think the implementation of these automated systems is being treated is being a threat for the career or the livelihood of the manual laborers?
Well, absolutely. Absolutely. I 100% think that there is some threat. There is some threat. We also worked on one of the projects where we wanted to fly some drones over the construction job site in order to collect data. But we found that there were immigrant workers working there, and they're not comfortable about the fact that we are collecting all this data, we are surveilling them. Although the purpose of surveillance is to increase safety, but they don't know that. But I think you brought up a very important question that um, and a very important concern that and how do we really protect our existing workforce from becoming obsolete or becoming obsolete to all these technologies, like because if we can quickly understand that okay, this person is not productive, there might be a situation where we want to fire him and get somebody better, but that not should not be the way. Right now we are also working on some models that would be able to give you productivity rates, but not with individual level. Like for example, we will design the system in a way that will actually hide individual level details. It will show you as a team. And from that team, you know that okay, this is your tag team. This is their overall productivity. This is the task they were assigned to, right? If you're not doing individual tasks, this is the group task they're assigned to. This is their overall productivity. So you can always change those things. Apart from that, in the midst of high productivity demand in construction. Another thing is the industry also needs to look into how they can take care of their existing workforce before firing somebody. If they fire somebody just because of productivity, uh, they're also losing knowledge. They're also losing experience because that worker might have worked in the company for 5, 10 years. So if you fire somebody just because they cannot work, you are losing all that experience and knowledge that they have gathered. So in that case, what they should do is they have to look into that data. So you actually brought up a very important point. Once they look into that kind of productivity data, that's when they know that something is wrong. So when they see that something is wrong, firing is not the only option. There are other options that we can consider. For example, option number one would be to train that worker that, okay, this is the type of construction work and this is the most efficient way to do it. So training and education is something that's very important. And I think that is something that can help. One is training, and second would be some of the assistive technologies. Today, I have shared examples of many exoskeletons, and those exoskeletons are actually mechanized. That's mean when your productivity is low, you're not getting that support from your body. Those exoskeletons or wearable robots actually provide you that additional support that can hike up your productivity and get back to the original one.
So, sir, basically, you are saying that the overall